Good morning, ladies and gentlemen. Today we're going to talk about important points about graphs and graphs. We're going to learn all about graphs. Okay, so first things first, let's talk about graph. I just said that. Okay, most graphs are two number lines arranged to show the relationship between separate quantities. So what do I mean by that? Let's start with this one. Number line number one.
That looks familiar, Ms. Moore.
This is from our Walkthrough lab.
Oh, yeah.
Oh, yeah. So number line number one, number line number two. So these two number lines are put together and we can see the relationship between time and position. Now remember when I showed you guys how to do this trick, right? Okay, and we could bring the paper down and we can see what's going on. We can see over time what position people are going and essentially how fast they're moving, right?
Yep.
This guy moving fast and this guy is moving fast and this guy. All right, so let's do the same thing with Quizlet 2. Ba-dum, psh. Here's Quizlet 2. It's a position versus time graph. And the first thing I'm going to do is I'm going to turn it sideways. I know.
Why do you do that, Miss Moore?
You know, it just makes it easier to read, easier to look at. So again...
Well, there's your number line.
Oh, yeah. Okay, so let's talk about this. So here's my number line, and again, this is position. And this way we have positive position, and this way we have negative position. And on my x-axis, we have time. So time going down this way. What we're going to do is we're going to talk about how to describe the motion of this object as we move through time. So I'm going to go ahead and cover it up. And as I move this paper back,
Ooh.
Yeah, this is the 1 second mark right there. 1 second. Yeah, one.
So where did it start?
So it starts at 0, right? It's starting here. And as 1 second goes by, I want to know how could you describe the motion? And in other words, how could you describe the direction?
What? Going from 0 to 2.
Yeah.
That's,
well, is it all the way? It is. Is that 2?
It's 2.
Yeah, it's 2. Okay. So as I keep going, so what you're going to do, well, I'm going to keep going here actually. So what we'll do is we'll keep going as we go from 1 second to 2 second. Is it?
Oh.
Is it moving?
It's just staying in the same spot.
Okay, and as I go from 2 to 3.
Oh, wait a minute, it's going, is that backwards?
Okay. And then as I go from 3 to 4.
Oh.
Now don't forget, we can also describe this as going in the positive or the negative direction, or forward and backward. So what I want you guys to do, actually, let me actually act this out first, and then I'll talk about what I want you to do.
I like that, acting.
Drama queen, okay. All right, so should I just right here?
Yeah.
Okay.
So where's 0? Make 0 in the middle.
0 right, oh, good idea. 0 is right here. 0, okay. So I start from 0, and I'm walking 2 meters. First second, second second, third second, fourth second.
Yep.
Should I do it one more time?
I think because it doesn't stop over there on the negative side.
Oh shoot, you're right.
Do it again.
I gotta do it faster. Okay, here we go. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi.
Sweet!
Okay. No, I was so focused, I'm like, am I doing this right? You know, it takes practice. It's a little confusing. So, thinking about how I'm going, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. Okay.
Oh, yeah.
All right, so here's what I want you to do.
If they're confused, they could go back and watch that again.
Watch what I do. The
That's
second
right.
time around. That one was the better one. So, the graph below shows the motion of an object over time, just like you saw me walking. Describe the motion of the object for each time interval. So down here, I want you to pause the video. And from 0 to 1 second, describe the motion of the object. Use words, just like how we talked about. If you don't know what to do, go watch the last minute. Okay, 1 to 2 seconds, describe. 2 to 3, and 3 to 4. Do it.
Okay.
All right, now that you've done that, let's talk about slope. The slope on a graph is the rise over the run.
Wait a minute, is this a math class?
I know, this is like my worst nightmare all over again. I just remember, so is it geometry, algebra? Whatever, okay. Welcome to physics. So the slope is the rise over the run. The rise over the run, okay. So, or delta y over delta x. Y, x, okay, that's enough. We know how to do math. On a position versus time graph, like how we have over here, the slope is the velocity. Let me say that again. The slope is the velocity.
Oh, that's like which one's going faster over here.
Yeah, right? Remember how we were talking about how, like, you know, the orange guy seems to be going faster because he's going further in the same amount of time?
Oh, yeah.
He's going faster. The slope is the velocity. Steeper slope, steeper velocity. Okay, so that means that we can calculate the velocity, right?
We could by finding the slope.
We could by finding the slope. Okay, so don't forget, velocity, the average velocity is displacement over time. Now, displacement is not distance. It's the straight line path from point A to point B.
Yep.
Displacement over time. So, positive or negative slope shows the direction of the velocity.
Positive and negative. Which ones are positive? Which ones are negative? Yeah,
so, sorry, we're talking about the slope here.
Yeah.
Okay. So, positive or negative slope shows the direction of the velocity. So, if it's positive, it's going to be going up, right?
No, it's going in the positive direction.
Sorry, it's going in the positive. Going up.
Was I right about that?
If it's
inside joke.
If it's positive, it's going to be going in the positive direction.
There you go.
Don't forget, we've got position over here, meters, right? Direction.
What's the slope in that next one?
The slope here. Well, okay. Well,
Looks
positive
like
is this way. Negative's that way. Is it going either one of those ways?
No, that's 0, isn't it?
0. Okay, so it must not be moving.
That's right.
Okay, so now what is the direction of this slope?
That's negative slope.
It's literally, you know, it's going, dare I say it? No. Okay, negative slope. And then this one is positive slope. Okay.
Positive or negative slope shows the direction of the velocity. I get that.
Okay. So, let's look at a new graph. Here is our equation for average velocity. And what we can do is we can calculate the average velocity. I need not a pencil. I need something more serious, hardcore. Okay, so here we go. Let's go ahead and calculate the average velocity for all 3 of these segments. We'll start with the first one. Good place to start. Okay, so I'm just gonna go ahead and write out my equation first. So I know, actually, should I use the T-chart?
I'm gonna.
So in order for us to graph this, we need to know what the times and the positions are.
That's
so
right.
Let's go ahead and get the data. So, don't do that. Time is on the x-axis and on the xy. That's confusing. X-axis, y-axis. Time, position. Time, position. Okay. So at time 0, our position is 0. So I'm just gonna write 0, 0. I'm gonna go ahead and move this closer for you. And then at time 200.
No, we want the end point.
Oh, shoot, yeah. And then at time 600, and that's a positive right there. It says positive 1200. Okay, sweet. All right, so now that we have our stuff, let's go ahead and look at our equation. So velocity equals the change in x over the change in time. Okay, so x2 minus x1 over t2 minus t1. And I'm just going to go ahead and put this down here because I'm running out of space over there. So x2, okay, so my final is going to be this one, okay, my final is going to be this one. I know, this is my life. Okay, and what's my units? Meters? Meters? Minus my x1 is going to be 0 meters, divided by x2 is 600 seconds, come on, some more, minus 0 seconds. Okay, so essentially
that one's a dead soldier.
I got one right behind you over here. We'll do again, my life. 1200 divided by 600 equals 2 meters meters per second. Meters divided by seconds. Okay, great.
So that means
that the velocity right here, the slope, which equals the velocity, is 2 meters per second.
Sweet.
Sweet. Okay, let's do number 2. So again, I'm gonna do a little t time velocity, time and position over here. Okay, so at time, we're gonna do this point and this point. Okay, start, finish.
Oh, that's okay.
So for section number, for the second segment.
Yeah.
So we start at time equals 600 seconds. And we end, and right, 1200.
Well, that's where we were before.
Yeah, right?
I get it.
Now, okay, where are we ending at? Well, we're ending at, that says 1,000 seconds. Oops, seconds. And we're ending at the same place. 1,200 meters. All right, let's do this. Velocity is vx minus x1 divided
Some
by...
of you can do this in your head already.
And if that's you, do it. And if it's not you, that's okay. Okay, so x2, 1,200 meters. Huh. That's going to be...
That's going to be 0.
That's going to be 0, right?
Yeah.
And then 1,000 seconds minus 600 seconds. But that doesn't matter, huh?
Yeah.
So my velocity is going to be 0 meters per second.
And that makes sense because the slope of the line is 0.
Yeah, we're literally not moving. So we can't have any velocity.
No.
Right? We're chilling. Okay. Let's take a look at number 3. Okay, number 3. Oh, and let me go ahead and write that. 0 meters per second. Okay. 3. So, T-chart, time and position, where we at? So my time from here to here. So this one, my time is 1,000 seconds. And my position was, again, 1,200 meters, okay? And then over here, this says 1,800 seconds, and I'm ending at what looks to be like 400 meters. Okay, let's do this. Velocity equals x2 minus x1 over t2 minus t1. Okay, here's my x2, 400 meters, minus my x1.
That's a little minus a big.
Yeah, a little minus a big. Okay, divided by, and again, 18 minus 1,000 seconds equals, okay, so I'm going to get, so I get 400 minus 1,200. Wow, okay, so negative 800. What is that going to mean? And then 1,800 divided, delete, minus, miss more, minus.
I think it's going to be 800 seconds.
Yeah, oh, yeah.
Oh,
okay.
wait a minute. I don't think you're going to need a calculator for this one.
No. So I get a negative 1 meter per second. Why is it negative? Well, okay, so up here we had a small number, and then we had a big number minus a small number right here. So we got a negative up top. And then if we look over here, we can see that this is a negative slope, right?
That's right.
Negative slope, negative velocity. It makes sense. Didn't we just say that? Okay, negative slope shows direction of velocity, negative velocity.
So it's going backwards.
Yeah, and then for our first one, we had a positive slope, right? Positive slope shows positive velocity. Positive velocity, positive slope.
Going in the positive direction.
Need I say more? I
Sweet.
think we're good. Okay. All right, so done with this, done with this, done with this. Oh, we are back to Quizlet 2. This is not a mistake, ladies and gentlemen. We need to develop our skills a little bit more here. So, actually, I will have to keep using this. So we're going to do the same thing. Right now, you should have a description of what is happening from 0 to 1 seconds, 1 to 2, 2 to 3, and 3 to 4. You should have described the motion of this object or of this person walking. Are they walking forward? Are they walking backward? Tell me. Now, I want you to explain using numbers. So we have to calculate the slope. Remember, the slope is the velocity. So here we go. First things first, let me actually go ahead and use my...
Are you going to do it for them?
Oh, should I have them pause? What I want you to do is pause right now, and I want you to collect the data points. So for when time equals 0, 1, 2, 3, and 4, I want you to plot the position. So at 0 seconds, where is it? At 1 second, where is it? At 2 seconds, where is it? At 3 seconds, where is it? At 4 seconds, where is it? Write those numbers over there. Okay, now that you've done that, because we have to show them the thing, the arrows.
Oh, yeah.
Yeah. Now that you've done that,
Oh, yeah.
at 1 second, we're at 2. At 2 seconds, we're still at 2, because we haven't moved. At 3 seconds, we're at -2, and at 4 seconds, we are at 0. Okay.
So we've got 4 line segments and 5 sets of numbers.
Yeah, okay. And so what's gonna happen is, if you guys don't mind, I'm just gonna actually rewrite this right here. So we're gonna do some math. And I'm gonna show you the easiest way to organize this, I believe. Okay, so we're gonna group these numbers.
What do each one of those mean?
So these are each of the time segments from, so this is gonna be our first time segment right here. This one's gonna be our second time segment right here.
Oh.
This one is gonna be our third one right here, and this one is our fourth one right here.
Beautiful.
Okay, and what are we looking at here? Well, again, we're looking at the slope, the velocity. The slope of the line is the velocity. So don't forget my equation, velocity equals x2 minus x1 over t2 minus t1, and we're gonna use this here. So I'm gonna go ahead and calculate this first one with you guys.
Okay.
The first one with you guys. So just to show you how it works. So I want to put my position, my x2 right here. Okay, so that's my second one, my x2 right there, and we're talking about meters, minus my x1 is right there, 0 meters. Okay, and then I'm going to divide it by my time 2. My time 2 is 1 second minus 0 seconds. 2 divided by 1 is 2 meters per second.
That's easy.
Okay, I'm gonna set this one up with you, and then I'm gonna let you finish it, and I'm gonna let you guys do these two on your own.
Sweet.
Okay, so again, we need x2 minus x1, t2 minus t1. So here's my numbers right here I'm dealing with. x2 is gonna be this one, minus x1 is that one, divided by t2 is this one, minus t1 is that one. Oh, I forgot all my units. Meters, seconds, seconds. My answer will be in meters per second. Okay, whatever you get there. Solve this, do this, and good luck.